Hello everyone. In this video we are going to talk about an integration which is looking so simple, but we do not know of any direct formula for integrating such a function, right? E power x minus box x. E power x we know how to integrate, but what about x minus box x or even e power box x dx? We do not know how to integrate that, right? So there is no such direct formula, and therefore this problem is interesting, and this is also important, I believe, for math interviews. Anyway, this problem came in this WBPSC 2022 for recruitment of assistant professors to the degree colleges. And if you are liking the content of this video, kindly take a moment to like this video, and of course subscribe our channel for more such videos. Well, in the problem, this integration, this function is given. First, before we solve this problem, I want to mention some of the integration rules. For example, what is a to b fx dx is exactly equal to integration a to c fx dx, okay, plus c to b fx dx. Okay, this is even true if if this midpoint c is outside the interval ab, but in general this is true for any c, but here we need only this a less than c less than b. So if c is in between a and b, this point is in between a and b, then we can break like this. Or this is also true even for more than one point. For example, a less than c1 less than c2 dot dot less than b, then you can actually write all these integrations. So clearly this integration can be written as 0 to 1 e power x minus box x dx plus, I will not write this function again and again, 1 to 2 dx, right, plus 2 to 3, okay, dx, so on, plus 99 to 100 the function, and then dx. Okay, and there is no doubt, because this is a very popular and easy formula which we learn in integration, right? So this is true, right? Now what we can do is we can actually calculate these individual integrations, okay, all these individual integrations, and then sum them up, right? So what we can write in a compact form is this: I equal to 0 to 99, okay, integration from I to I plus 1 e power x minus box x dx. This we can write it. So we want to just calculate this individual integration and then want to do this sum. Well, so first part, the first integration is this 0 to 1 e power x minus box x dx. Okay. So as we have mentioned already, there is no direct formula for e power x minus box x. Okay. So therefore we have to understand the underlying concept of integration. What does it mean? Okay. So integration is nothing but, so suppose a function is given, okay, then the area under that curve, right? Area under that curve. In general, so function may be negative, then you have to consider the negative area, okay. Anyway, so but the functional values, what are the functional values is the only important part in this problem. So here x is in between 0 and 1, right? 1. And we know that this integration does not depend on the extreme point. So for example, this is 0 and this is 1. The integration 0 to 1 of some function f will not depend on the functional values at 0 and at 1. At 0 it can be anything, at 1 it can be anything. If in between this is same, then 0 to 1 integration will be same. Okay. So we can actually exclude these extreme points, okay, two extreme points 0 and 1. Similarly, for each interval we can remove the extreme point. So rather we will consider x belong to open 0 1, okay, x belong to open 0 1, this is belong to open 0 1, okay. Now for x belonging to open 0, 1, what is x minus box x? What is x minus box x? So x is x, no problem, but box x, when x is in between 0 and 1, box x is actually 0, so therefore it happens to be x. So x minus box x is nothing but x on this particular interval, right? So now we shall do this integration. So here is the equal sign. So 0 to 1, this, so we know that now by analysis that x minus box x is nothing but just x. So it is e power x, e power x dx, and which is e minus 1, very easy to calculate, right? Okay, the next question is, what is 1 to 2 exponential x minus box x dx, right? So again, if the integration is from, let's say, 1 to 2 and there is some function, the extreme values, okay, the functional value at the extreme point, they do not do anything to the actual the value of the integration. So we can just take here in this case we can just take x belong to 1 open, 2 open, okay, 1 to open interval. So for this x, for any such x, x is actually 1 plus, let's say, t. Then where is t? T is actually in between 0, t is in between, so t belong to open 0, open 1, right? X is 1 plus t. So then what is box of this? So x is x 1 plus t. So x minus box x, if we want to calculate, then x is 1 plus t, but box x is box of 1 plus t when t is in between 0 and 1, but there is no integer between 0 and 1, right? So this becomes 1 plus t minus, what is box of 1 plus t then? If t is a fraction, box of 1 plus t is the greatest integer, which is 1, right? Sorry, it is 1 plus t. So this becomes t, right? So t is in between 0 and 1. So x minus box x, it is exactly like t when t is from open interval 0 to 1. Okay. So here we can actually write this as 0 to 1, okay, e power t dt. And now we can find out the integration very easily, right? Now it is so easy. So again it will be e minus 1, right? Again it is e minus 1. So for the first integration here, we got e minus 1, right? For the second integration, the second component, we again got e minus 1. We shall also, so basically to revise things, we shall also calculate for the third component 2 to 3 e power x minus box x dx, right? This is what? So again 2 to 3, the idea is what? The idea is this. So these functions x minus box x when x belongs to 2, 3 is same function as x when x belongs to 0, 1. This is the catch and this is the understanding, okay. This is all which is there in this problem, nothing else, okay. This is same as this. We could also write same as t when t belonging to 0, 1, because x equal to 1 plus t will do the job, right? And then dx equal to dt, right? There is no harm in that. So each such integration will be of this form. Now you understand that why this, because this gap everywhere it is 1, right? So 0 to 1 e power x dx, or you could write e power t dt. So this is again e minus 1. But how many such integrations are there? So starting from 0 to 1 plus 1 to 2 plus dot dot plus 99 to 100. There are 100 many, right? 100. but each of the integrations are giving e minus, each of them is giving e minus 1, right? So the answer is this 100 e minus 1, and this is the final answer. Okay. Okay, so that's all in this video. This was actually important. Okay, and yes, I thank you for watching.